Hi, today we'll be looking at a teardown and review of the Tekpower TP3010E switching power supply. As you can see, this one is a unit that I got on Amazon for about $130, and it's very small and compact as we would expect for a switching power supply. If this was a linear power supply, it would be much larger. There's nothing so special about this. It's a standard single output 30 to 30 volts, 0 to 30 volts at 10 amps. So it's really quite nice. It's 300 watts in a very small package like this. And let's tear it down and see what's inside. So before I do a tear down, I just wanted to compare it with my existing linear Tekpower TP3005D power supply. And for this power supply, it's a dual channel, 0 to 30 volts, 5 amps each. So if you think about the power wattage, it's basically about the same, but it's significantly larger and significantly heavier than the Tekpower switching power supply, even though it's both of them about 300 watts. And as you can see, the linear power supply is significantly larger and heavier. And this one is much smaller, much lighter, and definitely easy to carry around. So in terms of performance, we will not expect this Tekpower TP3010E switching power supply to do as well as the linear power supply, mostly due to the fact that it's switching. And indeed, if we look at the datasheet, this little unit here has a 100 millivolt peak-to-peak regulation, which is not that great. But if you need a small compact power supply that you can carry around and can provide 10 amps of current, this might be something you would be looking at. As for the cost, the switching power supply is just about, I bought this for just about $100 on Amazon, and it's significantly cheaper than most other switching power supplies of this class. Therefore, I would not expect it to be of extremely high quality. However, I think hopefully it will be good enough, and we'll take it apart and we'll see how it compares to more conventional $300, $400 switching power supplies. So for this unit, I actually found that there was a problem with it. And this is a problem that some other people on Amazon have found. And the problem is that sometimes when operating the unit, the LCD display would actually turn off. So let's see if I can reproduce this. So let's turn it on. As you can see, it has the standard voltage and current control knobs. And it's nice that they have a fine and a coarse control knobs, which gives you a bit more fine tuning on the actual voltage and current that you want to set it to. But I found that sometimes if you increase the voltage knob too fast, the LCD actually turns off. Let's see if I can make it happen. And there you go. And this LCD, once it turns off, the voltage is actually still correct. It's just that there's probably some sort of bug in the LCD. And the only way that I found that to get any sort of display back is to turn off the unit, wait for the capacitors inside to discharge, and turn the unit back on again, and that would allow the LCD display to come back on. Alright, so now it's turned off. Let's turn it back on, and there you see. So now it's working fine. The knobs are clearly working. But sometimes when operating the unit, the display can suddenly turn off, and that can be quite annoying. So I sent an email to Kaito USA, who is the distributor of this Tekpower series of power supplies. And after some investigation, they managed to find the problem. And they told me by removing a few components on the circuit board inside, I should be able to fix the problem. So and there you see the LCD just turned off again. So this video will turn out to be a repair video. See if I can repair this using the instructions that they've given me. And after that, we'll take a look at the power supply and its internal construction, and hopefully once it's working, we can review it. So before we do a teardown, I just wanted to go through a quick overview of how a basic switch mode power supply would be like. And this is just my guess of what it might be inside the Tekpower power supply. And we can see if we can find the components in this very generic switch mode power supply, and if we can find the same components inside the Tekpower. So for a basic switch mode power supply, we'll have a few main parts. So we'll have the mains input, we'll have a switch, the main power switch at the front, we'll have a fuse that will go through some EMI filtering. So I'll expect to see some common mode choke, some other filtering, some inductors, and we'll go to the main bridge rectifier. So in some of the higher end power supplies, I would also expect to see some sort of power factor correction circuit, some sort of pre-regulator. But I don't expect this Tekpower to have this circuit inside given its low cost. Once we have DC, this will go into the bus capacitors. So we might see one or two large bus capacitors which will store the high voltage after rectification. And this is where we can now do our DC to DC conversion. So I will also expect to see two main power transformers. One of them would be a small one, and this would just be a small power transformer that would provide the power for the logic, and this could be like a simple buck converter topology or some sort of other small switching power supply. And this would provide the 5 volts for the logic and power for the LCD. Now for the main DC to DC converter, I would expect to see, of course, we'll see maybe a circuit board for the front panel, and this will control the voltage and the current sets for the main power supply circuit. We'll have a basic driver circuit. I'm not expecting anything fancy, maybe some sort of TL494 PWM controller. And this will likely be controlling, for example, a half bridge of MOSFETs, and this could be powered by a gate drive transformer. We'll see this main power transistors powering a main transformer, and this main transformer would then provide the main isolated 30 volts 10 amps. We'll see it being rectified by some large diodes over here. It will probably go through a main inductor for filtering. We'll have an output capacitor, and I'll also expect to see a voltage, some sort of voltage feedback that goes back to my driver circuit and front panel. And I'll also expect to see a large current shunt, which will be able to let the circuit know how much current is drawing and therefore keep the whole supply regulated. So this is a very basic overview of a switch mode power supply, and once we do a teardown, I'll go through this circuit and that power supply, and we'll see if we can find the main components inside. Alright, so the power supply came apart easily enough, just removal of 8 screws holding the case. And what I'll expect to see is maybe one main circuit board and maybe a few other boards for the front panel. So let's see what's inside. Wow, exactly as we expected. We have one main circuit board holding the main components. With a fan here, we have the main IEC input jack. And we have 2 circuit boards over here, one for the front panel, one for the LCD. Oh, and we have one more right here for the output terminal jacks. And that's exactly what we expected. So before I do a in-depth review and before I go through the circuit board itself, I'll go ahead and do some of the modifications that Kaito told me that I should do to make sure that the LCD display does not turn off. So basically fixing the problem. And apparently the fix involves removing some components from the front panel LCD, which on first look looks very nice indeed. But I was told by Kaito to remove some of the components here, and after that we'll go through and see if this fixes the problem. Now, in order for me to remove this board, I have to remove this ribbon connector, but as you can see, it's actually glued down. So that's a very nice attention to detail, but too bad I'll have to cut the glue out and see if I can remove the board and get the little fixes that I have to do on the LCD board to get this working again. Alright, so I found that I was actually able to get my soldering iron inside over here without actually removing any of the ribbon connectors. And I was able to remove the 4 components that I was told that would be able to fix this problem. So what I removed was these components. We removed R22 over here, R21, this capacitor here, C8, as well as C11. So I've removed these 4 components, and now it's time to plug it in and see if this actually fixes the problem. Alright, so I've plugged it in, and as you can see, the case is removed. So this is quite dangerous, but we'll be very careful not to touch anything inside the case. But let's see if we fix the LCD problem. So let's go ahead and turn this on. Right, it works, and I found that the best way to induce the LCD to turn off was to set it around 5 volts and then quickly increase the voltage. So let me play around with this a little bit and see if it works. Right, seems to have fixed the problem. So that's good news. I can't seem to get the LCD to turn off. Previously, I found that the LCD tended to turn off. I'm not sure if you can hear it, but sometimes there's a little hiss from the power supply, and that's due to the switching frequency of the transformers inside, and it tended to go off when the hissing was the loudest, which was at some particular range of voltages, and it does not seem to do that. So I suspect what could be the problem is that there was some sort of interference going on at some sort of resonant frequency, which might be interfering with the drivers of the LCD, but I'm not very sure since I don't have a schematic. But it looks like this fix is successful, and it seems to work. Right, so it's time for the teardown, the proper teardown, and let's go through the different components inside the circuit. So I have to say that on first impressions, this looks like a very impressive unit. As you can see, the inside is completely powder coated. It's in the case is made of a very nice powder coated steel finish and not some cheap galvanized steel that one would expect from a made in China product. But so far the construction looks very good. We can see that all the components are basically housed on one single-sided PCB as we would expect. And we can see that the main power transistors are mounted on a big aluminum heatsink, which basically forms the back of the case. Now please be aware that because this power supply has been connected to the mains before, I made sure to allow the capacitors, the main bus capacitors, to discharge before servicing it. So you should definitely not touch any part of the circuit before the entire power supply has been discharged. Otherwise that could be very dangerous. So for the main supply, on first glance it is very nice. Let's take a look at the main connectors. As you can see, we have very nice heat shrinking done on the main IEC input jacks, so that's heat shrink, and they've even gone to the trouble of insulating everything with clear tubing. So that's a very nice attention to detail right there. So main tubing then goes all the way to the front where the main switch is. So it's a big power switch at the front, and we can see that the ground connector is nicely crimped and screwed on with shake-proof washers, so that's nice attention to detail, exactly what I would expect over there. And we can also see there's another ground wire that goes off to the front panel. Alright, so now let's go through the main components of the switching power supply. Now we can see the power comes in through this IEC jack, and we have a fuse that's right inside the IEC jack. The power goes through these cables directly to the front panel, to the main switch, and the power gets sent to the top left corner of the board. We can see the power cables are completely heat strinked in clear tubing, so nice attention to detail. We have a NTC, negative temperature coefficient, for some protection. We have some filter capacitors as well as a large common mode choke. After that, the power goes to the bridge rectifier and gets stored in these two bus capacitors, and I suppose they are in a twin configuration. We can also see that some solastic over here, that capacitors have been gunked down so they won't vibrate loose, so that's nice as well. And this is basically the main part of the circuit where AC is converted into DC. So if we refer back to our circuit over here, schematic, we can see it basically has all the components that I expected. So we have the fuse, it goes through a common mode choke, some filtering, and then we go through a large bridge rectifier. And one thing you might notice that's missing is I can't seem to find any power factor corrector circuitry over here, but I guess that's to be expected with a power supply of this price range. Alright, the next thing we would want to look at is where are the main components. So we can see these look like the two main transformers. So this one looks like it will provide the logic power for the logic for both the front panel for the display as well as the PWM circuitry. And we have this large transformer, and that's obviously the main switching transformer. And we can also see this large inductor, so that's definitely the output inductor. We have some filtering caps over here, and we have some big cables that transfer the power from the power section of the board to the front panel. Now let's take a look at the logic power supply over here. As we can see, there is a single main chip of interest over here. And I went to look it up. This looks like a power integrations component, and it's the TNY277. And what that is a completely integrated offline switcher with good for 18 watts and has an integrated 700 volt MOSFET as well as built-in oscillator. And that definitely powers this transformer up at the top. You can see over here. So we have this main transformer over here, and this breaks out into the ribbon cables that send power to both the front display as well as the other side of the board that controls the PWM circuitry for the main switching transformer. Alright, so now let's move to the main power section of the board. We can see there's a main power transformer over here, and as expected we have a nice large capacitor that's set, and we have two main MOSFETs over here. So I went to look up the part numbers, and these are the FDP12N50N, and these are 500 volt 11.5 amp N-channel UniFET 2 MOSFETs from Fairchild. So this is basically exactly what we expected. We expect to see two main MOSFETs here, and what I think this is, that looks like the main gate drive transformer. And so this is that main gate drive transformer over here. And if you look over here, there is indeed a secondary daughter board. And if you look closely, I'm not sure, you probably can't see it here, but there's an IC on the other side, and that is indeed, as we expected, a TL494 PWM controller that's used not just for generating PWMs but also used very commonly in switch mode power supplies. So this is exactly in line of what we expected. So I'm quite surprised that they actually went to the expense of using these nice MOSFETs, and as you can see, these are the special kind that are actually already isolated, so they can just screw it directly to the main aluminum heatsink, but these are usually more expensive. So it's nice that they actually bought it to use some nice components over here. We can look at the main transformer. So it's nothing so special about that. It's exactly what we expected. And after that, we'll expect the main filter. So we have a large inductor over here. Has to be beefy enough to carry the 10 amps. So that's why it's so large. And we'll also expect to find a diode, and if we look closely, we can see this large TO247 package over here, which is the main diode. Again, I tried to look up the part number for that, and that turns out to be a on semiconductor MUR3020 power rectifier, and that's actually a very nice 30 amp 600 volt power rectifier. So I am quite impressed with the selection of power components on this board. Overall, the layout is very nice. As you can see, good single-sided construction. Nice slot, a good attention to detail over here, which separates the high voltage side on this side of the board with the low voltage side over here. And we can also see the generous use of Solastic used to hold down the large components of the board. And I'm a bit disappointed that there doesn't seem to be much Solastic around the main filter choke, which can be quite heavy. And if you imagine if we had this unit on a table that's on a push cart around the factory, it might vibrate loose, as well as these large capacitors. But I guess for the price point, and if it's just sitting on your bench, it should be fine. So again, let's take a look again. Oh, and just one thing to mention. This TO247 part is actually a 3-pin component, and what it actually is, there are actually 2 diodes inside this component, and they're both connected together in the middle. So if we go to our main power supply schematic, which I drew up, this is exactly in line of what I would expect. So we have the main transformer over here. We have these 2 large bus capacitors, and at the output of the main transformer we have the 2 diodes, and these are connected together. And we have the main inductor as well as a large output capacitor and a current shunt. So where are these? Let's take a closer look. There we are. So we have the main output capacitors, we have some extra inductors over here, and this large beefy thing is definitely the current shunt. So that's where the power supply will be measuring the voltage drop across this and would be able to determine how much current is flowing through. And that basically wraps up the main components of the power board. So it's exactly in line with what we expected, and I'm quite impressed with how neat and tidy and how small and compact the layout is. Even the quality of the PCB is surprisingly good. It's if you can see, it's actually the nice fiberglass FR4 material and not some of the cheaper phenolic kind that are used in cheap power supplies. So I'm quite impressed by that. So just another look at a different side of the board. We can see the main components as we described. There's a fan over here. It doesn't seem to turn on, so I suspect there's some sort of thermistor or temperature probe in there which turns on the fan when the whole heatsink gets quite warm. But I really do quite like the construction of this, where it basically just uses a large aluminum plate as the heatsink, and the 3 main power components, the diode and the 2 switching MOSFETs, are directly connected to it. So that's very nice. Now, one thing to note is the brand of capacitors. Let's see what we have there. So we have some, I guess it looks like some no-name Chinese brand capacitors. So these probably could be a bit better, but I guess they are reasonable given the price point of this power supply. And just for good measure, here is a close-up shot of the main control board for the power supply, and we can see the main IC that's doing all the work. That's a TL494PWM IC. So, and those of you who are interested, for the front panel LCD display circuit board, we have 3 main ICs. We have a microcontroller over here. We have a standard LM358 op amp, and we have just a basic LCD driver over here. And if we look at the control board, we can see the potential meters that are used for the voltage and current knobs, some trimmer resistors over here, and that's basically it. For the output jacks, they even made a small daughter board just for that. If you can see that, they actually have a diode at the bottom over here. I'm not sure if you can see that. So there's a protection diode at the bottom, as well as a large 1000 microfarad output capacitor. So usually in a precision power supply, you wouldn't want such a large capacitance on the output, but in this case, I guess since this is a fairly it's a fairly high current 10 amp power supply, and you'd usually be driving quite a large load with it, and in order to smooth out some of the switching noise that we expect with a switching power supply, I guess it's not too uncommon to find a large 1000 microfarad capacitor on the output. So overall, I'm actually quite impressed with this Tekpower power supply. It's very small, very compact, and I really like how they did the layout inside over here. The board layout is exactly what we would expect for a power supply of this price point. The only thing that maybe I would have liked would be a power factor corrector front end for a little bit more regulation, but otherwise it looks like a very nice power supply unit, and now that we have fixed the LCD problem, it looks like it would be a very good addition to any hobbyist who's looking for a reasonably good quality but yet low cost switching power supply. So now that we're done with the teardown of the power supply, let's go ahead and put it back together and we can do a review of its performance. Now, for those of you who are concerned about the initial LCD problem that we had, Kaito USA told me that they have fixed the problem for all the new units. So if you go ahead and buy one right now, the problem should be fixed and it should be exactly the same as this model after I've removed the 4 components. And if you happen to buy one of the older models, you can easily perform the fix. I'll post details later on which components you can remove, but this seems to have fixed the problem completely, and now we have a nice working power supply. Alright, so now it's time to test the power supply, and for those interested, this model happens to only be a 120 volt AC unit, and I didn't see any sort of tab that you could use, and according to the specifications, it does say AC 110 volt only, so they probably have a different model for a 240 volt line. So let's go ahead and turn this on, and the first thing that we'll like to measure is how accurate the front panel voltage is. So according to the specifications, they will expect for the LCD to have 1% plus 2 digits accuracy, and let's see what it has. So let's try this without a load first. Let's go up to let's say 12 volts, and it's nice to have both fine and coarse control knobs, and it comes supplied with some standard banana jacks. And let's measure the voltage, and we'll expect it to be 12 volts. And so we have it there. It says 11.94 volts, which is within 1% and 2 counts, so I think that's within specification. Alright, so now I have a 20 ohm resistor, power resistor over here, and let's see how it does with a load. To make things easier, let's set it to 10 volts. And as you can see, it's reading 9.988, so that's definitely within the 1% plus minus 2 digits. So if we connect this 20 ohm resistor, we'll expect to draw about half an amp. And let's see. So yep, exactly, it's drawing half an amp over here through our resistor, and now we'll go ahead and go with the current measurement to see how accurate this display is. Alright, so now let's test the accuracy of the current meter over here. According to the specifications, it's supposed to be 1% plus minus 2 digits. So let's see how it compares with my multimeter. So as you can see, it's 0.5 amps over here and 0.949 amps. So that's 2% accuracy, but still within the plus minus 2 digits. So we can say that this meter is within specification. So right now the current limit is near maximum, and we'll connect this and turn it down and see how accurate that is in the low sides. So it's drawing half an amp now. If we bring it down, it should pop into constant current mode. And there we have it, constant current mode. And it's 0.36 amps over here, 0.35. That's exactly what we expect. 0.35, about 7 volts. Again, this all makes sense since this is a 20 ohm resistor. Drop it even further. It seems to be working great. 0.32 amps and 0.319 amps. So I don't actually have a power resistor or some sort of electronic load capable of testing out this power supply at its full 10 amps at 30 volts load. But what I do have is I have a very nice, powerful Delta DC brushless fan that supposedly draws 4.8 amps at 12 volts. So I guess let's test instead and see if this power supply is capable of supplying 4.8 amps for this powerful fan. So let's go. So I've set my current limit to maximum, and we'll slowly turn up the voltage and see if this power supply is capable of keeping up. So the power supply clearly has no problems supplying about 4 amps required to power this fan. Alright, so what I want to test now is the ripple of the power supply, and what I have is I have it connected to just a standard power resistor over here, and this is connected to my Rigol oscilloscope. And if you can see over here, I'll just zoom in into my scope. You can see that I've set it to AC coupling with a 20 megahertz bandwidth limit, and I'll go ahead and set maybe about 5 volts or so at about a quarter amp through the resistor, and we will zoom in and see what sort of ripple we are getting. So if we take a close look, we can see that in general it seems to be just about, over here we have 50 millivolt per division, so we have just about two divisions over here, and this seems like most of the noise is concentrated within the 100 millivolts, so it seems to meet its, generally seems to meet its specifications. But you certainly wouldn't want to use a switching power supply like that for any kind of precision work, and for that you'll probably be better off using some dedicated precision power supply or a linear power supply, which would have much better performance than a power supply like this. So now I've set the power supply to 10 volts across a 20 ohm resistor, and let's take a look at the turn on performance. And I'll turn on the scope. And there we have it. Now I've disconnected the load, so it's basically just the output of the switching power supply connected directly to my scope probes. And let's see the turn on performance. Very nice. So as you can see, nothing special about it. Overshoots a little bit, maybe by half a volt or so before it stabilizes. So now I've set my Tekpower to 20 volts, and across a 20 ohm resistor that should be 1 amp. And let's see the turn on performance again. Very nice. Over here we have basically negligible overshoot, so it seems to be working great. And now let's do a reverse of that, and we'll look at what happens when I turn it off. Very nice. Basic capacitor discharge as we would expect, since there's a 1000 microfarad capacitor on the output, but nothing special, exactly what we expected, and no spikes, as it doesn't seem to have any spikes during switch off, so that's working great. So that concludes our Tekpower TP3010E 30 volt 10 amp switching power supply. Overall, I'm very impressed with this unit. It's very small, very compact, very light, and has surprisingly nice internal construction for its price, and its performance is exactly as what we would expect for something at this price range. As you can see, very compact. That's how the back looks like. Yep, overall, I'm quite pleased with this product, and I would recommend it for anyone, any hobbyist looking for a compact power supply. So I'm happy to report that the Tekpower TP3010E switching power supply has rightfully earned itself its place on my electronics workbench, where it will join my Tekpower linear power supply. If you enjoyed this video, please check out my website where I have more photographs of both power supplies, and as well as discussions and lots of other projects that you might be interested in. So thank you very much for watching, and catch you next time.